Hey guys, Chris Gamble with Chris Gamble's Analog Life, and today I'm actually, it's a weekend, so I'll get some free time, and I'm going to be cutting some more stuff today. But before that, I wanted to actually make sure that the mill is actually cleaned up, leveled, actually do some of the stuff I probably should have been doing throughout, but I'm going to show some of the stuff that I do regularly. This isn't really going to be a video for people that are already experts, because I'm probably going to show some stuff wrong, but things that I do to try and make sure that it's all operating correctly still, and maybe even try some new things and get it all cleaned up and ready to go for the next cut. Alright, let's get to it. Let's get cleaning up. So first off is the oil. When I first started, I just had this in the garage, and it actually worked out that it worked okay. I mean, so it's a 10W30, pretty simple, but it is synthetic. So you know, and there's a whole bunch of stuff online. You know, I saw people talking about mixing in WD-40 with it and all these other things. I think basically you don't want to run your mill without any lubrication on it, which is obviously pretty smart. I mean, like, you don't want to, because when I showed them how I was leveling the mill and setting the ways and stuff like that, you could see that it's metal sliding on metal. You want to make sure there's actually lubrication in there. So anything's better than nothing, but again, you don't want to then just lubricate with WD-40. You want to maybe clean with it and somewhat lubricate. And again, I'm not an expert with any of this stuff. I've hardly done anything with oil. I never fixed cars, you know. It's kind of sad, actually. I never really changed my own oil. It's something I'm planning to get into more, but just haven't done it yet. So, but one of the things that the factory or someone, I think it was actually, so Deep Groove. Deep Groove is a company that actually buys TIG mills, which is what this is, and then they resell them as kits. And they'll actually sell you like a Gecko, like the same controller I have, and some of the steppers and everything. I think it was them who suggested Mobile One, and it might have also been the TIG factory. But basically, this is just a 10W30 viscosity. You know, it's a synthetic. It's nothing fancy, but this is the one they suggested. So why do anything else? One of the things that I think that was going into that decision, though, was the fact that this thing can also help clean alongside, you know, actually like get some of the particles away, which is usually a secondary function of motor oil, as far as I know. So anyways, they were talking about syringe because it's really easy to apply it. I couldn't actually find a syringe. I talked to a couple different places, at least not in the size that I needed. I found this one here, but this is way too big. So I ended up going to a hardware store, found an oil can, immediately started thinking about Tin Man in Wizard of Oz. But you know, it's real simple, just a pump action, and that actually allows you to apply the oil. It's got a little flexible hose, which is nice. So it's simple. I mean, that's what I really wanted. I wanted to be able to simply apply oil, and then I'll be able to, you know, apply WD-40 as I need it as well. So you know, different places I put it in on the mill. Let's see. So definitely on all the pathways here, on where the ways are, any of the adjustment points. I need to actually move the mill in order to get to some of these other ones. I have some very poorly squared up stock on here, and this is just that pink foam I was using the last time. But you know, you can see kind of back in here, these on these rails up front here, and so what I'll do is I'll move the mill around to all different locations to try and, you know, wipe out all the pink foam particulates, and then also get in all the motor oil where it needs to go. So you can see that from a prior cut, it actually gets pretty grody down in there, and this is actually something that I pulled off from when it was. This is how it showed up, but there's actually it's like a little skirt, I guess, that can actually screw down to this. This is actually the back one, I think. But this actually screws down to here, and I probably should end up reinstalling this. But basically, its idea is to cover up this area here, and then also cover up the motor mount and the actual stepper motor. So I might actually end up doing that again. I'm not really sure yet, but and you'll see that in other mills as well. You'll see like these accordion-looking things that actually protect the back, and it's really just to keep that stuff out of there. So this is just a simple way of doing that, but for now I'm going to have to clean this out, and then, like I was saying, I'm going to oil inside here, and then put some oil on the actual lead screw. Where else? And then when the X table moves, I'll be able to. Oops, sorry. I'll be able to actually. I can move the X table around, and get oil in there as well. So I want to make you actually watch that, but that's just some of the areas, and you can see that there's already some particulates and such. So I'll oil this up, and then we'll move on to the next item. Okay, so one of the things that I did is when I was moving this all around and kind of cleaning it up, I was kind of leaning on this thing. Actually, this happened yesterday as well. I was actually replacing this belt. I'm not sure why it happened already, but the belt already needed to be replaced. And when I was pushing against this, if you remember in the first assembly video, there's a screw back here and a nut that actually holds the Z-axis on there. And so what I did is actually got out of alignment. So this is actually a well-timed video because I can show you how I actually align this thing. So it's kind of hard to see. Hopefully you'll be able to see it here. But there we go. So basically, when you're aligning the mill, this is the Z-axis here, like I talked about before. What you're trying to do is you want to make sure it's square against this square that I have here. So this is designed to be, you know, decently square, a 90-degree angle. So what I do is I set this on the table, and then I line it up against the Z-axis, and I want to make sure there's actually no light coming through there. It kind of looks like there is because there's still some foam bits, but basically that's how you line it up. And I've got this gauge here. So this is that gauge I showed in a past video. This is a 2,000th gauge, and if I can slide this in there, then it means that it's not square and I need to readjust it. Now luckily I've already done this one, so it does show that it's square, but I can also move the Z-axis down, not too far, because I need to make sure I don't run the end mill into the table. And you should be able to see it's square all the way down. So that's just another check you can do to make sure it's square, both sides. Obviously, if it's on one side, it should be on the other, as long as this, I'm sure this piece is square because this was made at the factory. But again, it shows that nothing really can get in there, no space. I've also heard you can do that with a piece of paper, that a phone book page is like 2,000th or something like that, so that's another check you can do to see if it gets in there. So next I'm going to do a dial indicator I have. I have this big dial indicator. Which is good for certain things, but the dial indicator I want to do is actually for what I think is called tramming the mill, which I'm going to make sure that where the end mill comes out, when you do an alignment, or sorry, when you tram along here, that it shows that there's no variation because of a slant. So I already tested the Z-axis to make sure it's square against this, but if there's a slant, you know, I could move the mill down and then re-square it against the Z-axis, but tramming also shows that it's that the Z-axis here in the spindle is indeed level with the X-plate. And I haven't done this before, so this might actually have some implications. I'm hoping not, but it might. Okay, so first thing I got to do is take out the end mill I have in there and the collet. And what we're going to do here, this all the way off. You can see again, this is what I showed in the previous video. This is this part here. Come on. Damn. Well, this is the actual end mill. It's a flat end mill. This is a 1/8. I think it's 1/8. Unless I've been doing these cuts wrong. It's a high-speed steel 1/8, and then the shaft is actually 3/16. So the collet I have in here is a 3/16 collet, because that's actually what it grabs. It grabs onto the shaft, and then oh, I knew this one. The flutes? No, it's called something else. This section is called something else. The flutes are the individual. This is a 2-flute cutter. You can kind of see on the end here, there's 2 flute. You can get 3 flute, 4 flute. I think it keeps on going up as well. But that's a 2-flute cutter, and then it grabs onto the shaft. Ah, man. Probably not supposed to do this, but pop this thing out of there. Ah, finally. Again, this is the collet. This is what actually, when you tighten it down, it actually grabs onto the shaft there. Also cuts fingers, apparently. Okay, so what we're going to do instead now is, I think I actually might need this collet. So this is a tiny dial indicator I got off of Amazon. And what this thing does is I can slide this onto here. It looks like there's multiples actually. There's two different connections here. So I can do a small or a larger one. I'm probably going to do the smaller one because I think I actually have something that'll fit that. But basically you can slide this on like so, and then the dial indicator hangs down. You can move this around. And what you do is you can turn this thing, and basically if you're touching the plate here all the way around and it doesn't move at all, then you can tell that the mill is actually level, or the table is actually level. My cuts have been looking okay so far, but I haven't done any precision stuff yet. And you can see that with the dial indicator, it's quite sensitive. I mean, you just put tiniest little touch on there, you know, and that's tiny little touches move the dial quite a bit, and then you can adjust it too. That's how you effectively calibrate it. So I'm going to install this here, and then we'll try and get it in, see what it can do. Okay, this might be kind of hard to see, but I do guarantee that this is at 0. I set it to 0 right now. It doesn't matter because it's actually not touching the mill yet. But I set it to 0. I actually had to end up having to use the 3/8 collet, which is the biggest one I have, and I think the biggest that can fit in this ER16 collet set. But this one actually turned out to be a 4mm, so it was set for metric. So the collet systems I have, it's all fractional or imperial. So what I'm going to do is I'm going to lower the table, lower the spindle, and then once it contacts, it should come to some setting here. And then what I'll do is I'll start to rotate it. Hopefully not in the rotational section. This thing just wants to come right out of here. So I'll rotate it from up here, and from the top. I'll rotate this, and then if the number moves, then I know that one side of the table is higher than the other, and that there are some alignment problems. And I'm pretty concerned that that actually is going to be the case, but won't know until we try. All right. Please excuse the steps. All right. So right now it's about 5 thousandths or 5 mils. So what I'm gonna do is I'll start rotating this thing. You can see as I rotate it. Oh, so I kind of jog there. Now some of this might be because this cutting plate is this could be not machined perfectly flat. It probably is because it's done by the factory. It's pretty. I think it's just a piece of stock with a bunch of taps and then some drill holes for where I actually mount the T-nuts. But it looks like that jog might be catching the edge of one of the drilled holes as well. Alright, looks good so far. I'm not sure how much you can see there. It looks good. It's in a mill. It's off still. You can't see it back there. It's about... Oh, that's a hole. Yeah. Okay, so apparently when it dives into the hole, you can see that. That's the problem. Still about 5. Another hole. Yeah, okay. Well, that's better than I thought it was going to be. So, it's about 1 mil total. It dives a little bit more when it's in, when it hits a tapped hole. But, yeah, you can see that, it's still at about 5. So 5-ish. I'm sorry, it's kind of hard to see. I'm trying to find a better lighting solution here without blinding everything too. So yeah, so the tramming worked. What we can do then too is, let's see, how can I do this? So I'll leave it like that, and hopefully you can see the reading. And what I'll do then is move the table this way, and then you can see if the table is relatively flat as well. Let's see. Went down about another 1,000. Then yeah, obviously there, went down a lot. Let's go the other direction. Looks like it's about oh yeah, you can see the needle starting to climb there. Uh-oh, almost just pushed the other dial indicator off the engine bench. And whoa! Oh, jeez! Well, I scared the hell out of myself there. As you may notice, the stepper's at the end. That was really dumb. I was watching this thing expecting it to go off the edge, and then I hit the end. So let's, there we go. Oh, one of these days I'm going to burn out one of these motors. I hope not, but yeah. So yeah, it looks pretty good. I can do the other direction too here. I can do the Z, or the Y as well, which is this direction. Not sure if you can still see it. It's still about 4 or 5. It might dive a little bit because of the hole, but I don't want to hit the back of the plate either. But yeah, that looks okay. It's a little bit, it's probably got 2 or 3 mils on the front, so that's not great. But again, it's tough to tell with this thing. I think, you know, this part of the table, the actual table is made to be perfectly flat. I'm not so sure about the this drilled out work holding table. But for me, for right now, I mean, I'm not doing anything precision yet. You saw that last cut. So so this looks pretty good, and this is actually the first time I've used this dial indicator. So it's a nice little piece of equipment here. Now I can mount it. The other nice thing about this, not sure how much you can see this thing. Let's see. The nice thing about this one is you can. I put it on the top here. You can also mount it here. You can also mount it on the back, and I'm not really sure what that's for. Maybe to get like a Z movement if I wanted to mount it to this. I don't even know. But yeah, it can be mounted on different surfaces and stuff. And like I said, you can get this adjusted so that it's so it's a cool little tool. I like it. You know, it's not like a huge range. Some of these other dial indicators, like this one, this will go like a whole inch, I believe, or whatever that is in 25 millimeters. So this one, you can see it actually has a secondary indicator here, which actually tracks total tenths of an inch. Yeah, so this, you can see it's written right on there. This does an inch total. So yeah, they're nice. This one's not as useful as I thought it would be, but I'm sure I'll find uses for it eventually. Yeah. So for right now, this looks better than I thought. Oh, jeez. Knocking stuff over. So it's cleaned, it's oiled. Yeah, cleanish. It's cleanish. It's oiled. It's leveled, or square rather. The Z-axis is square. The spindle is the tramming looks okay. And I think we're ready for another cut. So I'm not sure what other measurements I can do. I mean, I could do this. I had leveled, like I had actually leveled this before, and that looks okay. But it's not that this does. You know, the actual leveling of this, like the true level, it doesn't matter nearly as much as the leveling against this thing, because the whole table, you know, could be tilted, and then this would show as being an absolute level of not perfect. So I think what I'm going to do next is put these things back on, get these little skirts reinstalled just to make sure I don't get more gunk down into the channel down here, because I don't know if you can see, but it's pretty gunked up already. I mean, it's pretty grody. So and it's hard to get out of there too. I mean, that's the worst part about it. So since I will be cutting more foam in the near future, I'll probably get rid of that. Alright guys, that's all for tramming and leveling and oiling up the mill and cleaning, I guess. But this will be continuing on. I mean, I'm not sure if I'll include it into future videos, but it'll definitely be something I have to do pretty regularly, because otherwise it's going to get gunked up, and really then it won't last. And the thing that I've been counting on is that this mill is going to definitely hold on for a couple years, and that me taking care of it is going to make it a worthwhile investment. So speaking of investments, one last thing. Based on some suggestions from readers, or some listeners rather, and from some coworkers that have done other types of projects, I decided to make this little air scrubber. It's pretty simple. It's just a box fan with a cheap air filter, or furnace filter attached. So this thing will kick on, and hopefully it'll pull all the particulates through it. Then I'll be able to change out the filter whenever it gets kind of gross. But hopefully that'll show up in future videos too, because you know, you'll see as it gets pinker and pinker from the foam, at least, as I move on towards metal wood and metal and other things, I'll move. I've been planning on putting in like a flood cooling system, and that always helps a lot with reducing chip count and that kind of thing for metal. So hope you enjoyed it. See you next time. And you can subscribe if you want to. And hit the thumbs up thingy. Thanks.